the next series in a deep learning tutorial. And you remember in the last tutorial we talked about how you can actually build a computational graph. So, and after we have built the computational graph, you see how we do back propagation to be able to update our weight matrices. Now, there are certain intuitions that we actually observe when we do back propagation. The first one is the plus node distributes the upstream gradient. Remember that for us to be able to calculate our downstream, we multiply the upstream with the local stream. So now, for instance, now what we mean that the plus node distributes the upstream gradient. For instance, in this place you have this is um, by the time we did back propagation, we got 2 here, and we got 2 here, and we got 2 here. You will see that this computation, this node is actually computing addition, and this upstream 2 is distributed to each of the input to that particular node. That's what we mean that the plus node just distribute whatever is the value of the upstream. The max node routes the upstream gradient. Now here, this is the max node. What it does is that we have 3 here. What does it do? It routes the upstream gradient. That is, it routes these 3 to the input that actually has the highest value. So here, the original input are 2 and 0. So by the time we did back propagation, this 3, which is the upstream value, is routed to this place that actually has the higher value. And this is given 0. So this is routed just to the max of the 2 input. And the star node switches us the upstream gradient. So what we mean here is that in this star node, we actually have this one comes in as 3, and this one comes in as 2. But you see that by the time we do back propagation, these 2, by the time we did back propagation, this one that is 2 becomes 3, and this one that is 3 becomes 2. That is what we mean that it is swap. So the 2 that was here is not the value that we have here, and the 3 that we have here is not the value that we have here. That's what I mean by switches the upstream gradient. Alright, so this is how we can do back propagation, implementing it in code. So what do we do? Essentially, we just define a function. This function takes in all these our input, w0 x, w0 x0, w1 x1 up to w2. That is what you have in this place. And you can calculate our s0, which is going to be w0 multiplied by x0. You can have intermediary variable for s1, which is w1 and x1. You can have s2, which is the addition of s0 and s1, and you can have s3, which is the addition of s2 that we have here, and w2, and you can squash our s3, squash the s3 into sigmoid. So the backward part, it computes gradient. So this is how the gradient is actually computed. You see that we start with the first, which is differentiating the loss by itself. We give us 1. Then we calculate the the local stream multiplied by the upstream, okay, give us the downstream. So this is the local stream multiplied by the upstream to give us the downstream, and we continue to use that in our calculation. Okay, this is the base, and you can see how this is. So you have the sigmoid of the S3, so this does the sigmoid. Yeah, this does the sigmoid of S3. Then this actually corresponds to this. This does that, and this corresponds to this part. This corresponds to this part, and this corresponds to this part. So that is how we actually do our uh, backpropagation using flat code. We're going to continue from here to actually look at how you can do a two-layer neural network with flat code. Thank you for listening, and see you in the next one.